Math 76, Lesson 18, Average and Line Graphs. So the concept of average, if you've not had it explained to you yet, I actually like the way that the book demonstrates this, is we can describe this with these stacks of books. So the way average works is it's like trying to find an ideal number. So if we look at this top area, these stacks of books, we've got one stack with 1, 2, 3, 4, 5, 6, 7, 8 books, another stack with 1, 2, 3, 4, 5, 6, 7 books, and then the last stack with a lowly 3 books. All right, so we've got 3 stacks. We've got 8, 7, and 3 books for a grand total of 18 books. And what average is, average wants to know if we were to even all 3 of these stacks up, how many books would be in each stack. And you can see what they did here in the diagram. What they did here is they took 2 books from the first stack, they put it on this lowly stack of 3, making it up to 5, and then they took 1 more and they put it there. So they made all 3 stacks even. They didn't change the number of items. They're just showing what it would look like if it were even. Okay, in actuality it looks like this, but the average would show us how to evenly distribute something, right? And they find out that if we were to average it, there would be 6 books in each stack. So the way that you conduct an average mathematically is you take the total number of items you're dealing with, in this case 18 books, right? The 8 plus 7 plus 3, and then you divide it by the number of groups you have, right? So let's go ahead and check that mathematically. So let's say we took the stack of 8 books, we added it to the stack of 7 books, we added it to the stack of 3 books. We would get 7 and 3 is 10, 10 plus 8 is 18. And then from there we would take the number 18, we'd divide it by the number of stacks we have, which is 3, or the number of groups we have. 18 divided by 3, 3 goes in 18 6 times, 6 times 3 is 18, balances out. We should probably already have that one memorized. So 6 books in a stack, so that checks out, that's good. And that's the method we're going to use every time we average. We're going to add up for a total number, then take the total number divided by the number of groups we have. Let's do this in one more example problem. Let's say in 4 classrooms, so we've got 4 classrooms. We have one classroom of 28 students, one classroom of 27 students, one classroom of 26 students, and the last classroom has 31 students. And we want to find the average number of students in each classroom, or the ideal number, right? So what we're going to do is we're going to take these 4 numbers, we're going to add them all up together, and I'm going to use an algorithm for this one because that's quite a bit of numbers to keep track of. So I'm going to use our vertical addition algorithm. 8 plus 7 gives me 15, plus 6 is 21, plus 1 is 22. So I put the 2 down, I carry the 2. 2 and 2 is 4, 6, 8, 9, 10, 11. So 112 students total. So that's my total number. And again, I have to take this total number and divide it by the number of groups. And I have 1, 2, 3, 4 groups. So I'm going to take 112 and I'm going to divide it by 4. 4 will not go into 1, so 4 goes into 11 2 times. 4 times 2 is 8. We subtract, and 11 minus 8 is 3. From there I bring down the 2, and 4 goes into 32 8 times. That multiplies perfectly, and we're left with 28. So the ideal number is 28 students. And I'm going to go ahead and remember to label my answer. That way I know what I'm talking about. That's it for averaging. It's that simple. You add them all up, divide by the number of groups, and that's your average. Now, let's talk about line graphs. So just like bar graphs, line graphs can display information, but they use a different method of doing it. Instead of using multiple bars over periods of time, I have a continuous line with different stopping points, right, along the line. So here at the top, I have the title of the graph, which is Margie's height. Always got to have a title above your graph. On the left, I have height in inches and then numbers going up. On the bottom right, I have age in years and numbers going to the right. So this is when she was 8 years old, 9 years old, 10 years old, 11 years old, 12 years old, etc. And then this height in inches, this would be 44 inches, 48 inches, 52 inches, 56 inches, 60 inches. So if I wanted to know how tall she was at age 10, I'd go to the 10, I'd go up to the dot. She was 52 inches tall at age 10. Now, the thing to notice about this bar graph is, this line graph is they're skipping more than 2 numbers. So from here I go from 44 to 48. So if I'm going from 44 to 48, that means 45, 46, and 47 are all in between these 2 numbers. And that means that halfway in between 44 and 48 would be 46, because half of the distance of 4 would be 2. So 46 is halfway in between. If it's closer to 44, then it's probably 45. If it's closer to 48, then it's probably 47. So we can use that estimation to kind of help us figure out where the numbers are in the graph. So let's look at age 9. At age 9, we see that the dot is exactly halfway in between 48 and 52. So what number is halfway in between 48 and 52? Remember, the distance is 4, so if I add 2, that puts me at 50. All right, so at age 9, she was 50 inches. Let's look at another age. Let's see here. Let's look at age 11. At age 11, we go up, and the dot is in between 56 and 60. Now, would you say this dot is halfway in between those two numbers? No, I wouldn't either. Excuse me. The dot seems closer to the 56. And since we know that there's a distance of 4 in between them, we would know that halfway in between 56 and 60 would be 58. So, if it's not halfway, if it's not at the if it's not at the 58 mark and it's just below it, but it's above 56, what's halfway in between 58 and 56? Well, that would be probably 57. So I think it's a fair guess to say that at age 11, she was about 57 inches tall. And then we could also do addition and subtraction problems from here. Like, for example, we could say, how much taller was Margie when she was 13 as opposed to when she was 10? So we'd go to 13, we'd find the height. At 13, we're halfway in between 60 and 64, which means she's 62 inches tall at 13. At 10, she was only 52 inches tall. So 62 minus 52 would be 10 inches. So she grew 10 inches from 10 to 13. So that's how you read a line graph. That's how you read a line graph, and you can still gather information from it like that. If you have any questions, let me know on the school's website, and I will see you in class.